about some of the cytotoxins. Am I correct, folks? So we talked about all of those. And the last one, amongst the toxins, there's a class which is also called the endotoxin or the lipid A. And we talked about all of these when we discussed the lipid A. Okay? So it's just the same repetition. So you can go back and look at the lipid A or the endotoxin because what are the symptoms? They all produce the same sign and symptoms, although to a different degree, depending upon the bacteria. But they are all almost the same overlapping sign and symptoms.
Actually, relating to the question on our exam that asked for 2 different ways that lipid A could be exposed.
We talked about 3 different ways.
Yeah.
Remember? And I only asked about 2 different. Oh, that also reminds me,
Antibiotics.
Maclysis, antibiotics, and the cellular death, how? By the phagocytosis. So those are the 3.
So they all basically just pertain to some form of death.
Anything which makes the cell, which target the cells and makes the cell vulnerable to death. Okay? Hey folks, I corrected a few, about 20 of those, either from this class or from the other section, I don't remember. But here's the deal, you know what? Tell me a good way, because I asked you to use the index card, and sometimes you don't even read I don't know, you are hyper excited or what? You don't even read the question carefully. I'm asking for something. Read the question. I think sometimes what you write on the index card, you just want to just poop out that part. Irrespective, I haven't even asked the question, and like some of the people, they write something which is irrelevant. They wrote a long, big one, but it was so irrelevant, and I realized. But it was very good answer. I did not ask the question, but whatever you wrote was good, but then I believe it was in your note card. Your note card had a very good notes on that one, so you just wanted to put it on that one. But I remember, I don't recall it offhand, but I was reading some of the things which I did not even ask those, but it was so well explained and written, but that was all irrelevant.
Did you give them points?
Oh no. I was glad to read. I was very excited to read it, but then I realized you might have done that part in your index card and just put it on as such. So don't do that later. The 3rd exam will be coming up sooner than later. So I want you to enjoy your spring break, folks. Okay? Because I know if you feel really fresh and after just a weekend away, getaway, I liked it. Yes.
So we haven't been able to review our first exams. We haven't seen them. So we don't really know what we got wrong on that. And then we also don't really know how you grade the written parts. Yeah. So that may have been frustrating for some people. I know it was for me going to the second exam and not really knowing points on the written part.
Here's the one.
You're looking for.
People had been coming and seeing the exam. People had been coming and seeing the exam 1 either after the class or before class. People have been doing that. I always say you can always welcome to see because people have come and seen the written part. I've showed them some of the written part, which was why did they get the full points. There was sometimes I also give extra credit points on the written part if they have written very nicely and everything to the point. So people have got extra points on that one. Okay. I think I did mention it last time also in your part 2 when I returned back the Scantron. The part 2 is the part. If you have scored whatever was the point, if you scored more than that, that means it was so good answer that I gave you like 4 or 5 points extra.
Okay.
But it's always open, you should have asked me. You should have asked me once, you would have got it all the thing, Okay?
Okay. When are
So,
our next quizzes?
let me just start here. This one I'll tell you. So the next class of an exotoxin. Exotoxins, there's another class of exotoxins which are called as super antigens. Just like the super dad, super mom, then you also have the super antigen. They are best described as some of the viral proteins or the bacterial proteins that binds to 2 parts, through the TCR, which is the T cell receptor, and to the MHC class 2 molecules. let me tell you a little bit background on this. Your defense system, your defense cells of the body, there are two major kinds of the defense cell. One is the B cells and the T cells. The B cells, they have a receptor on the cell surface, which is called as the B cell receptor. So these are the B cell receptor. These are the B cell receptor, which is, it recognizes some of the antigen. The T cell also have a T cell receptor. The T cell have on its surface some of the receptor, which is called as TCR. So these are the TCR or the T cell receptor. One of the major difference between the B cell receptor and the T cell receptor is the B cell receptor will be able to identify some of the PAMPs, and it will just pick up and it will chew it down into smaller pieces. And the B cell, normally it secretes antibodies. It secretes antibodies. Whereas the T cells, they don't secrete the antibody, but it mounts a more aggressive response towards the invading pathogens. And the B cell receptor would bind to the antigen, it will pick up the antigen, and then it will give it to the T cell receptor to recognize it. In short, in a very layman term, when I say it binds simultaneously to portion of the T cell receptor and to the MHC class 2 molecule. The MHC molecules are like billboards. On the cell's surface.
What does MHC stand for?
MHC stands for major histocompatibility complex. Major histocompatibility complex. MHC. So anytime pathogen, so here's what happens. The MHCs, they are like billboards on the cell surface. A pathogen which is picked up by the B cell receptor on the B cell, by the B cells, it is going to basically put it into fragment the pathogen. And then what it does, it has all this MHC molecule on the cell surface, and it is going to basically display like this all the small fragments of the pathogen.
The T cells?
The B cell will do that. There are other cells which are called as antigen presenting cell. B cell is an antigen presenting cell. And they will display this MHC molecule, which is containing a small portion of the ingested bacterial antigens. So these MHCs are like the billboards, and they display MHC molecule, they display fragments of the ingested bacteria or antigens. It's something like just like a billboard, which has some, like advertisement. So the MHC molecules are on the cell surface. They will be displaying, say, some of the, like, if this is an antigen which I picked up, I will break it down into smaller pieces, and this is the one which is being displayed on the MHC molecule. This T cell receptor, it recognizes those MHC molecule which is displaying the peptide fragments. Because the T cell receptor would not recognize a whole antigen, unlike the B cell receptor. The B cell receptor, you can make a note here that the BCR recognizes and picks whole antigens. Whereas versus T cell receptor or TCRs, TCR only recognizes peptide antigens presented by MHC class 2. So it only picks up and displays antigen which are being displayed by the MHC class 2 antigen. Is present by MHC class 2 molecule. So, to tell you in perspective, it's something like this. She's a B cell with the B cell receptor. So she picks up an antigen and then she displays those antigen on her surface. So can you hold this one? Or can you hold this one? This is the antigen which has been processed and she is displaying this antigen. This, her arm, and this one is the MHC molecule. I'm the T cell with the T cell receptor. I'm not going to recognize free antigen. I can only recognize the peptide antigen which is being presented by this MHC molecule from the antigen presenting cell. Does that make sense that way?
Yeah. So yes. The MHC molecules are on the B cell receptor?
The MHC molecules are on all of the antigen presenting cells. B cell is a type of antigen presenting cell. So those MHC molecules are present on the B cell surface. And there are MHC class 1 and the MHC class 2. I don't want to go into all the details at this time because at some point we'll be talking about those. Suffice to tell you, those MHC molecules are the ones which are matched. Whenever there is an organ donor and the organ recipient, if the MHC molecules are not matched between the donor and the recipient, invariably it leads to the organ rejection. So every time you talk about bone marrow donor, and I'm sure they always emphasize for the bone marrow donor and they need to be matched, is because the MHC molecules of the donor and the recipient need to get as closely matched as possible. If they are not matched closely, then what happens? There will be an immune response and the organ will be rejected. That's what they do always when they do a tissue typing, or they want to make sure before the organ transplant takes place, the MHC1 and the MHC2 molecule need to be all matched up. Yes?
What's the difference between the MHC1 and the MHC2? Not.
You know what?
Correct.
I would like you to know that part at a later time. Right now, let's keep it to ourselves.
Okay.
But I can tell you. The main difference, since you asked me, the main difference between the class 1 and the class 2 is, class 2 is only displayed by some specific cells, which are called as antigen-presenting cells, whereas the class 1 MHC molecule are basically expressed on all our cell surface. It's like expressed on all our cell surface except for the muscles and the nerve cells. They don't express, but the nerve cell again is a kind of a controversy. But the muscle cells and some of the other cells, like the liver cells, also do not express the MHC, and that's why liver transplantation is the most successful that way. Okay. Now, based on this background of information, the super antigen, what they do is they tend to short circuit the T cell activation. So normally, the antigen must be presented by the class II molecule and the antigen presenting cells, which could be the macrophages, it could be the B cells, or the dendritic cells. These are all the antigen presenting cells. You can also write your B cells, just leave it simple. So macrophages, the B cell are the antigen presenting cells. They have the class II molecule in addition to the class I, and there is a group which presents those antigen. Like this is the MHC molecule. If this is the MHC molecule, she has a groove here, and that's how she presents the peptide antigen to be recognized by the T cell receptor. Normally, that's the way it should be done. That's the normal way by which the MHC molecules, these are presenting the antigen, or antigens are displayed on this group of the MHC molecule, and then the T cell receptor recognizes those processed antigen, and they would activate the T cells. That's the normal way by which the T cell gets activated to mount an immune response. What the super antigen does, what I say is, super antigen, it short circuits the activation of T cells. The super antigens, SA, short circuits T cells activation. So instead of the normal pathway where the antigen is presented, the T cell recognizes, and then it activates the T cell, super antigen binds in such a way that the T cell will be activated non-specifically. And the best way to explain that, I tell people that it short circuits the T cell activation. So instead of going through the whole pathway what we just discussed, a super antigen is the one which a super antigen, like she's the super antigen. Can you hold this? She's the super antigen. What she does, she's going to hold my hand and they'll just do this thing. So she's the super antigen. So that's what the super antigen does. It short circuits the activation of T cell. It doesn't go through the normal process of antigen presentation and being recognized by the T cell receptor.
So basically just puts them together.
Pardon me?
So basically just puts it together for a bit.
Exactly. It does it non-specifically because the T cell receptor is very specific for that antigen. But the super antigen, it does it non-specifically, and one of the consequences, once the helper cell has been activated, there will be a massive secretion of some of the pro-inflammatory cytokine like the TNF1, TNF-alpha, and the interleukin-1. Those are the pro-inflammatory cytokine. It promotes the inflammation process for the elimination of bacteria. And once you have a massive release of the interleukin-1 and the TNF-alpha in an uncontrolled way, it would result in fever. It would result in shock-like symptoms. A sudden drop of the blood pressure that is a consequence of the super antigen or by the super antigens. It would also cause systemic clotting or the DIC. That's another aspect of the superantigens. So under normal condition, on a day-to-day, some of the conventional antigen or the regular antigen that would stimulate less than 0.01%. It's only 1%, 0.01% of the T cell responds to a particular antigen. But with the super antigen, because it short circuits the T cell activation, more than 5% of the T cell responds to the super antigens. We were not aware of the super antigen up until a few years back. And this whole process of super antigen started when some young menstruating woman, suddenly there was a spike in the number of young women coming to the hospital emergency with shock-like symptoms. And when they tried to go back, we found that there was a specific brand of tampon they were using. And that was a time when those tampons were being advertised that it has a better absorbability and blah, blah, blah. So it was collecting the fluid, and those fluids were getting colonized by some of the Staph aureus and some of the other bacterial species. And those bacteria was making those super antigen, it was secreting the super antigen, and because during the insertion of the tampon there were microabrasions. There were microabrasions in the vaginal wall, and those super antigens were being absorbed, and it was creating a havoc with the T cell or the non-specific T cell activation. There are two types of the super antigen. I know some of you have a question. Just hold on for a second. I'll just write it down. There are two types. So there are two types of the super antigens. One type of super antigen are called as exogenous super antigens. And the other ones are the endogenous super antigens. The exogenous super antigens are the one, they are some of the soluble protein which is secreted by the bacteria. They act like exotoxins. So in a way you can say the super antigens belong to the exotoxin because they're secreted. Like any of the other toxins, they're all secretory toxins. One of the classical example is the TSST of Staph aureus. Toxic shock syndrome toxin, TSST. I think you have it you have to write it down. Am I correct, folks? TSST is the toxic shock syndrome toxin. TSST. There are some of the super antigens which act as enterotoxin, but the one which is very clinically relevant is those ones which are secreted by the bacteria once they try to grow in the collected fluid. And those bacteria, when they're growing in the collected fluid in the tampon area, they make those toxins are secreted, they're absorbed into the bloodstream, and they cause this clinical condition of the toxic shock syndrome. When they came to know about it, then that was a time, there was all this advertisement, and now obviously you know better than me, that you have to change the tampons often, and you cannot keep it for an extended period of time. That was the one which was advertised earlier.
What one was advertised?
Oh, well, don't ask me, you know better, I don't know anything more than that. Now, that's one. The other one is the Mycoplasma arthritis supernatant. Mycoplasma arthritis is the one that causes chronic and acute arthritis. And that is more common It's more common in Mycoplasma arthritis. Supernatant is more commonly observed in some of the murine model, like the rat and mouse model, when they tend to use an arthritis model, animal model, they inject with the mouse Mycoplasma arthritis. So it causes both acute and chronic arthritis, and it's one of the murine arthrogenic compounds. This supernatant of the Mycoplasma arthritis, if you're trying to cultivate Mycoplasma arthritis with supernatant, it acts more like a superantigen. These are the classical examples of the exogenous superantigen. There are some superantigens which are part of the membrane proteins. Specifically, some of the viruses, some of the membrane protein which are encoded by some of the viruses that infects the mammalian cells. So on the virus, if you see a virus particle, then I'll write it here for you because I need to make a copy for tomorrow. So a virus particle like this, can you see, folks?
Yes.
How about you all? Can you see? In a virus particle, if this is a virus with its DNA, some of the virus particles have an envelope. So this is called as an envelope, which is derived from the host cell. It is derived from the host cell. When virus is exiting. When the virus is exiting following its replication, when it exits, it puts a membrane covering over it, and that's called as an envelope. And that envelope has some of the proteins, some of these envelopes have some of those proteins which are called as the spike proteins. These are the spike proteins, which are viral genome coded. There are some of the other proteins which are present on the surface, and those are called as, so like this I will make it. These are the endogenous superantigens. So these are also, the endogenous superantigens are also viral genome coded. The endogenous superantigens are also, these are also viral genome coded. So the beauty is, these endogenous superantigens, they are not secreted unlike the exogenous superantigens. The endogenous superantigens are not secretory, they are expressed. So when the virus is going to go and infect on a different cell, so when this virus infects, when this virus goes and infects a host cell, this is a host cell, infects a host cell, some of these superantigens, and I'm going to put it this way, some of these superantigens, this is what is called as an endogenous superantigen. And that's the host cell. When the virus goes and infects the host cell, this endogenous superantigen will still be on the host cell surface. a classical example when you see the endogenous superantigens is the MMTV, which is the short form of mouse mammary tumor virus. MMTV stands for the mouse mammary tumor virus. Mouse, M-A-M, and mammary, there are two M, there is only one M. Tumor virus, MMTV. Yes.
Is it mammary or memory?
Not memory, like mammary gland.
Okay.
There are two M's, am I correct?
2 M's.
Yeah, there are two M's, I'm sorry. Mouse mammary tumor viruses, that one is a typical example where the viral genome codes for what is called as an endogenous superantigen. Why it codes for that endogenous superantigen, we do not have a crystal clear clue about it, but some of the hypotheses have been put forward. One of the hypotheses that is put forward is, which is shown in the next slide, we talk about how the superantigen benefits the pathogen. Why in nature pathogen would try to secrete superantigen and makes our life hellish? There's a reason, because there's again no clear answer, but it's possibly because many of the T cell gets activated non-specifically. Because the superantigen short circuits, so much of the T cell will be activated. It may slow down a more coordinated response towards the invading pathogen. If it was very well regulated, then the T cell will help in coordinating the body's defense for eliminating the microbes. But if that defense response by the T cell is broken loose, then what will happen? Everything will be so messed up, the pathogen will have a better way without any interference of the defense system. Because the T cells are activated non-specifically, this is going to secrete a massive amount of cytokines, and that massive amount of cytokine would disrupt the cell and the microenvironment for a more productive defense response. It's something like there are the policeman who is trying to control a crowd. But someone goes and hurts the policeman, and then there are like hundreds of policemen are hurted, then what happens? They are not able to control the crowd, but the crowd takes an upper hand. Am I correct? In a similar way, the superantigen, normally they cause, like such a problem for the T cell. Instead of getting a very coordinated response by the T cell for the elimination of pathogen, now everything, the hell breaks loose inside because of the non-specific activation of T cells. And once the T cells are activated non-specifically, there will be massive release of cytokines, and basically it will be more favorable for the pathogens. Okay, folks? So this is all in all about the toxin, but before I get on, Andrea, you had a question and I didn't answer. Oh. So you're very quiet. I forgot to raise your hand again. What was your question?
Oh, I didn't have a question.
You didn't have a question? You had a question?
No.
Somebody else? Yes.
Small question. I'm curious, is this, like everything we've just gone over, is this in the textbook?
It's also there in the textbook.
It is.
Some of the things are not there. Some of the things
Sure.
because
But this part of the lecture, we can refer to the textbook.
Yeah. Superantigens are there in the
Okay,
textbooks. Superantigens, although this is taken from a different textbook, but superantigen
But
is.
something, we get the
Yeah,
general
yeah,
picture.
yeah.
Okay.
So this is all in all about the superantigen. Yeah, what was your question? Yes, I'm sorry.
The group for antigen, that this thing in the middle?
Uh-huh.
Like, is that, like compared to the billboard that you were talking
No,
about?
this is the billboard. This is the billboard. This groove is the antigen presenting groove.
Is that what that?
This
middle part
one, this part, the blue, this part is the antigen presenting groove.
is? Okay.
So your hand is
The hand is, I'm sorry, I'll just- this is the MHC molecule. This part where she's holding the pencil, this is the groove for the antigen presentation. The antigen, so this is the display thing, and this part is where the antigens are really, they are being held.
And the MHC is correct, it's in B cells, right?
It is present on the B cell, MSC class 2. It's present on the surface of macrophages, the B cell, and you are tempting me to tell you the dendritic cells too, which I didn't tell earlier, but those are the 3 antigen presenting cells.
Can you repeat that, please?
The B cells, so these antigen presenting cells are the macrophages, the B cells, the macrophages, the B cells. It also includes the B cells as well as the dendritic cells. Is that clear, folks?
I need
So
to
I
meditate on this.
Huh?
I need to really meditate on this. Can you?
The take home here is superantigens are a type of exotoxins which are secreted by some specific bacteria. And what they do is they short circuit the T cell activation non-specifically.
The antigen presenting cell, can you explain what that could be?
Antigen presenting cells is like a house guard, okay, who take an evil person, carry it all the way to the police station. So those are the antigen presenting cells. Like whenever those antigen presenting cells are maybe present at the periphery, like the dendritic cells, okay, anytime a pathogen is trying to enter your body, the antigen presenting cell will capture it, break it up into small pieces, and then they will go and present it to the T cell in the lymph nodes.
And the T cell will destroy it.
The T cell is, you can say, is like
Take
the
out the garbage.
T cell don't take out the garbage. The T cells are the one which is like a police head. The lymph node is the police headquarters, and the T cell is, you can say, another big time police officer.
So then what happens to it? after?
And then the T cell would release some of the cytokines, and that would cause or induce an inflammatory response.
That's a lot for like 2 slides. That's a lot.
You know what? No, it's because, I'll tell you. No. I want you to be happy.
You told us
It's
basically you're
not.
so helpful.
It's just the take home here is the super antigen short circuits the T cell activation.
What do you mean by short circuit?
What did
Short circuit is normally the antigen is presented in the groove and it interacts with the T cell receptor. Super antigen, you don't have an antigen presentation. Super antigen, this is what I said, normally she will be presenting the antigen and the T cell will interact with it.
Is it kind of like a catalyst to speed things up? Like the reaction?
It's not you can think about quote unquote catalyst.
Like to speed it up, right?
Yeah.
It's a shot.
I'm the super antigen. Look at me. Look at this. This is a T cell with the T cell receptor. Do you all get it, folks? I'm sorry. This is the antigen presenting cell with the antigen presenting group here. Do you all get it?
So
Yes?
there's an antigen
No?
in there. There's a
This is the processed antigen. But normally that would happen, but this is the T cell antigen presenting cell with the antigen MHC molecule. This is the T cell with the T cell receptor. This T cell receptor normally would interact with the antigen. You all get it? I am the super antigen. What I come and do is, I will go and bind both of them outside the group. And once I bind both of them, then just imagine she has a cytokine, she will release the cytokine unregulated.
Okay.
And once you have a massive release of the cytokines, like the TNF alpha and the interleukin 1, those are the pro-inflammatory cytokines. There's a massive unregulated release of the pro-inflammatory cytokine. So instead of doing anything good to the body, it makes the thing go worse.
Gotcha. Okay.
See?
So it's like the glue that brings them together.
Huh?
No, it's okay. I got it.
Excuse me.
Yes.
So why would the release of the pro-inflammatory?
Because the pro-inflammatory cytokine, once they are released,
Yeah.
they are the one that brings about the elimination of the microbes. Your
Yeah.
body,
But you said it would make the body go worse. But it's
because it's a large amount, there's an unregulated release of the cytokine. A regulated release of cytokine has a beneficial effect.
So what happens with the unregulated release? Why doesn't it affect the superantigen?
When super antigen is causing the unregulated release of this by the TS.
So why don't the cytokines, why doesn't the inflammation affect the superantigen?
Why it doesn't? Because there's no regulation. There's a global effect on the body. Your whole body defense system collapses. It's something like a police person is trying to control a crowd. And the police crowd is so large and there's no regulation, there's no order which is being done in a right
The
way.
police is just shooting like
Yeah, police is shooting, so what happens?
Well, it kills a bunch of people.
It's going to kill a bunch of people, but then what happened? The other public is going to be against the police.
But I don't understand why the superantigen is not affected by the mass expulsion
Here,
of the cytokines.
because everything hell breaks loose. When there's a massive release of cytokines, hell breaks loose. It's not able to get out of this
So can you
super
explain
antigen.
the MHC molecule again?
MHC1,
1 and 2?
put it this way.
Okay. No, just like, because the analogy is not helping me. I don't know.
The analogy of the MHC, they're like billboards. Okay? MHC molecules are always displaying some of the processed antigen on the cell surface. And that's how the immune system recognizes that some cells, when they're infected, they will either not display the MHC because some viral infection would cause the downregulation of. Yeah. And that's how there are other cells, then they recognize, oh, this cell is screwed up. Then they will mount a response to eliminate those cells. But MHCs are like surface molecule which is present on every cell surface will carry the MHC1. There are some cells which carries an additional MHC which are grouped as MHC class 2. And MHC class 2 are only present on the surface of antigen presenting cells like the macrophage, B cell, and the dendritic cells.
So the MHC class 2 are the only ones that the T cells are looking for?
The T cell responds to only the antigen which are carried on the MHC class 2.
Okay, and the T cells, so you said that the T cell only recognizes partial antigens that are on
Processed antigen.
Does that mean though that they learn from those processed antigens and then they go out and find those antigens on, because Otherwise, like, wouldn't they not recognize
Yes,
invaders?
because the T cell receptor, the T cell with a specific T cell receptor that will recognize of all the antigen. Like this is an antigen which is, what is this? Okay, I'll tell you this. This is an antigen. It has been well processed. Now, this is one specific antigen, processed antigen portion which will be recognized by probably one T cell. You see that? One T cell will recognize this antigen. The other T cell will be possibly recognizing the second antigen, processed antigen. So normally you don't have so many hundred of T cell activated at the same time. But because superantigen binds outside of those antigen interaction group, it non-specifically activates T cells.
I get that. I'm thinking if the T cell only recognizes processed antigens, how would that help it recognize whole antigens on invader cells?
The whole antigens are not, the T cell has nothing to do with the whole antigens. The B cell receptor, it recognizes the whole antigen.
So then only
The T cell basically coordinates the immune response.
okay. So the T cells aren't. Oh, yeah. Okay. Because the helper T cells aren't actually killing.
No, they're not natural killing. The
They're
helper
just
T
telling
cells,
go ahead.
the helper T cells are like
Call on
the.
other, like, white blood cells, right? So
Pardon me?
like, so pretty much the macrophage eats the bacteria, the pathogen, and it presents it to the T cells, like, you know, the T cells brings more white blood cells to,
There you go.
right?
Okay, so the super antigens, if it doesn't stick to the surface, then cytokines are not released, right?
No.
So that's the only thing they're useful for, to connect the outside of the surface.
Yeah, they bind on the outside of the antigen presenting group. And once they bind it outside, like I just showed you, I'm the super antigen, I just no, you don't have to read it. If I bind outside, then this is the super antigen, it will still cause the activation of the T helper cell and release the cytokines.
It's like a power cord.
Yeah.
Is there a good video you would recommend on this?
You know what?
You do.
Well, I know the videos, but then you just check it out. You know,
sure.
there are so many of the YouTube videos on the MSC, but cautious, a warning, folks. Some of those videos may be confusing. I don't need those videos, but I know the stuff. But for a layman, try to screen or try to get a couple of videos and then just watch it in YouTube, and you will get the basic, the take home. Okay. You don't look very happy on this one.
Break.
Yeah.
Huh? Yeah, break time, But check it out, you will get it, you will get it because super antigen. Oh my God, I talked an hour on super antigen. I can't do this.
Like this part. No, I was talking about like I think we got like. I think are you finished with your Yeah, I think I should. I'm gonna text it.